By default, the system will calculate all the process at the background. For 2.5D process, maybe that will be a bit slow. If you want to calculate a 2.5D process immediately, you have to go to preference under the NC, under the general preference, you can click on this, save and calculate immediately for the 2D functions, and just click OK. Right. Later you will see how fast it is. It will calculate immediately. And before I change something to let the process calculate, let me explain some more things. Now let's check this the motions here. If you want to change the color, the blue, the G01 motion, you can change from here. Any color you want. So I'm going to use back the blue. The red line is the rapid motions. So now if I use navigator, just select this process and right click navigator, and I can move the tools. You can see that it starts from the Z50 and move to Z3, okay, by a red color line. So this line is the rapid motion, G00 motions, and it will stop just 1 mm before the material phase 3, material phase 2. So this setting is where this actually here. Double click this process. I will show you where to change this. So the delta entry here, the delta exactly start is 1 mm. So you stop just before the material, 1 mm before the material. You can change it to 2. So I will change it to and calculate and use the navigator again. Let's check. You can see now the rapid motion stops at Z4, 2 mm before the material phase. Yeah. And next will be the approach. You can see the cutter. Let's go to navigator again. The cutter now is plunging, right? Plunging right into the material, and then after that there's a small motions. You will do a 2 mm approach, a small approach, okay, 90-degree approach, and then it will start cutting, and then after finish we'll have a 2 mm retract to this point and then go out. Okay, so maybe this is not good for our cutters. Okay? So I'm going to show you how to change the approach. So just edit the process again, go to motion parameters, and we go to approach. Do you see here 2 mm approach? So we don't need this one actually for this facing operation. So we should change to 0. The retract also no need. But for the extension, we do need the 2 to plunging outside the material. So I'll put 0.6 time. TLDI is the 2 diameters, is around 30 mm. So for the plunging, I will say a plunge, okay, 30 mm, extend it 30 mm outside, okay, into the air, and retract also I will extend it 30 mm also, right, and calculate. You can see now the approach and retract is extended. So now if I use navigator, you can see now the 2 is plunging outside of the material, right? Yeah. So next I'm going to set the stop width. You can see now for the face mill to cut only one part is not enough to face this part. So I need to put in some stop width. Let's go to motion parameters, and I will change the stop width here. Now it's 0. So I'm going to measure this using the measuring option here. Select this one and check this. It's around 90 mm, the stop width. So I'll key 90 mm over here, 90. And size set for the face mill normally is 0.7, 70% of the cutter. This is quite standard. It's good for the cutter. It's around 35. And then I'll calculate. And let's check, look at the navigator and the navigations. Let's speed up a bit and simulate. You can see now the cutter is moving to and back, okay, two directions, climbing and conventional milling. This is not good for the cutter, so I will change the cutter directions. Again, edit the cutter directions here, bi-direction, and change it to unidirections. And if you choose unidirection, then you can change the which mode you want. So I'm going to use the climbing mode and calculate again. So now the cutter is moving. Let's go to navigator again. One directions. Okay, now let's check again the face mill operations. You see that here up the face mill always jump back to Z50, the clear, yeah. So this is this will cause some cycle time. So to reduce this, the height of the clear, internal clear, let's edit the process again. Double click. Go to motion parameters, and where to change the clear, this is the area, the clearance, yeah. This is the clearance planes. This is where the tool will start from this level, and after finish it will jump back to this level. So this level must always higher than all your clamp and jig. And for the internal clear, you can specify here. So you can specify by two options. One is the absolute, the other one is incremental. Incremental means that if you key 1 mm, it will increment from the last position of your tool. Yeah. So this is quite dangerous if you don't know. If you are careless. So in this case, I will choose the absolute clear. So the absolute, and I will put maybe 10 mm. So I want all the internal clear to jump to absolute Z of 10 mm, and just calculate. You can see now the internal clear always jump to 10 mm. It becomes lower. Okay, and let's navigate. Okay, I'm going to move my cutter here and go to top view, and let's check. You can see here at the last part my tool is cutting tangent to this edge. So if you do this cutting, you might have some burr at the edge here. So to solve the burr problems, you need to do some offset. So how to offset? Let's edit these operations and go to motion parameters. The offset is here, boundary setting. Okay, so from here I'm going to key in a minus offset, minus 5 mm offset to overlap the edge and calculate and navigate. See here. Now my cutter will have a 5 mm offset at the side. Yeah. So it solves all the burr problems. Of course, after you offset 5 mm, offset this 5 mm, okay. If the stock base is not changed, that means the first cut, if we navigate here, the first cut of this face mill, okay, the side step will increase by another 5 mm, right, due to the stop width. So to solve this, you also need to add in 5 mm for the stock. So 90 plus the overlap of 5, right? So like that. Then the first cut will maintain back to 70% of the cutter. Okay. This is what you have to do to create the overlap.